Hello, everyone. Thank you for being with me here tonight or today, wherever you might be. And what a wonderful audience we have with us tonight. I'm Chair. I'm here to prop you up, here to talk a little bit about what is happening on Logos Testnet v0.1, which is live. I will not bury the lead. Logos Testnet v0.1 is live. If you go to build.logos.co, that is where the Builder Hub resides. That's not the view we want. We can dial this in a little better here. There we go. The Builder Hub is where you can find all of the resources that you need to get up and running immediately on Testnet 0.1. I'll skim for now, but the most important takeaway for you is build.logos.co. Of course, you can start at logos.co as it scrolls across the bottom of your screen. And while we talk about your screen, the screen that you are looking at, the screen that you devote so much time to, please like, retweet, share, subscribe, turn notifications on for wherever you are watching, be it YouTube, X, or wherever. Turn on notifications. Give the account a follow. Please and thank you. Once again, Logos Testnet v0.1 is live. That means, among many things, you can run your own node. You can begin developing applications for Logos Basecamp, for Logos in general. You can build all of the functionality that is and will be required for Logos mainnet. Go to logos.co to keep yourself informed. We will be imminently viewing a couple of demos that were shipped very recently from contributors Alishar and Václav. Alishar shipped a Logos Basecamp demo app. Václav, a multisig wallet for the Logos execution zone with his pal Jimmy, the Claude bot. We've had some other demos recently from Danesh, Atomic Swaps, and Sasha for Logos Scaffold, respectively. There are articles aplenty at press.logos.co. We'll dive into a few of those. You may have missed office hours, which happen every Friday. That is your opportunity to talk in person with a Logos core contributor. If you need more information, press.logos.co is where you can find all of the content. You should bookmark that page. It is also where you can find the Logos calendar. The Logos Press engine should be your go-to destination for Logos content. It will always and can always be found here, as well as community links. There is the aforementioned calendar with all of the office hours, and links to the meetings are there. All of the press and content in written form can be found, of course, at press.logos.co, and your leads to the Logos forum. An abundance of things to view. Press.logos.co. Now, because Logos Testnet v0.1 is live, developers now have the opportunity and no excuse to begin shipping. And they are doing that in earnest. I also have a storage demo for you, by the way, before I forget. Let's first go now to Alishar, who shipped a Logos Basecamp demo app. You can find Alishar at Alishar. Let me know how the audio sounds. I can see the chat, folks. If you want to give a comment, please do. But without further ado, here's Alishar. One moment here, as I suspect we might have some technical difficulties. Let me just make sure we're dialed in correctly. I think we are. Let me know, make sure the audio is coming through correct here, folks.
Easy framework. Now this is the new name, and this allows you to do similar stuff as Anchor for Solana. So it allows you to use Rust macros to define kind of the API of the program.
That's a big note there on the similarity to Solana in the framework for LEZ programs. So if you are familiar with those, then you should be able to get up and running pretty quickly.
And so that then allows for generation of set ADL, so instruction definition language, and then also CLI. So you don't have to write any CLI. This generation gives you that, and we'll use that actually throughout this demo. We'll also demo a spellbook, where spellbook is basically an on-chain registry for programs, which then allows you to fetch the IDL from Logos storage and use it in the CLI so that you can actually generate the transaction. And we will go through how that works. Now, in this repo, there is a branch, a tag called v0.1, and this is for our kind of current latest stable version. And the key part I want to point you to, apart from obviously all the code, there is this script directory which has a demo runbook, so you can basically do all that stuff manually that I'm going to show. But we also have a full demo flow script that does everything for you, and you can just watch it happen. And I'm going to use this just to make sure that I don't...
Just to make sure you're following there, that is, the full demo is available for you to run now, including all of the code and all of the skills, I believe, that Jimmy required.
I don't hit any issues. So there are a few prerequisites. First of all, we don't need to have sequencer running, but you have to have built, so cloned LSSA repo and build sequencer based on the README. We need the programs built.
If you hear
so
LSSA, that just means Logos execution
in the make file
for the context
for this,
of this video.
in the multisig, and then also the spellbook, the registry. And then, this is incorrect. It now creates its own wallet directory so that we don't have to, so we don't mess up your wallets in the home. There are a few environment variables that needs to be configured based on wherever your code lives. So you need to have the registry, the spellbook cloned. You need to have, this has old names, so I need to fix that. I'm sorry about this, but this should be either a easy registry for the old name or the spellbook for the new name. This is the current directory, so this should just be pwd, current working directory, and this is the path to your cloned LSSA, and this is so that we are able to spin up the sequencer, because that's what the thing does as well. Now we have a bunch of other things. They may change and evolve, so we will try to keep an eye on this. We create the demo wallet directory so that we don't mess up anything that you would have in your default wallet directory in the multisig directory. So in this repo, demo/wallet, so you can always clean it up and remove it. And we're using this environment variable for the LEZ wallet and the sequencer, basically to find wallets. Now I think this is basically most of the setup, and after that we should be able to run it. So I'm just gonna clean this, and I'm just gonna echo LSSA there, which is empty. So I'm gonna set it export LSSA there equals and mine is in home vbablin double GitHub Logos blockchain LSSA. Okay, and I believe that we should have the rest. I fixed some of the stuff here locally so that it actually fits in. So I have .lez registry for the spellbook program, and then pwd for the current directory for the current program. Now that I think about this, this may not be, oh no, it's okay, it's okay. Because I'm gonna just start it from here. So this is scripts and demo, demo. Now we can also do this, tail F,
Here comes the flow.
P, and let me find it here. We start the sequencer somewhere. Here's resetting sequencer, and the sequencer will log into a file. I think wipe reset here to sequencer log file. So we're gonna tell that. I already have something there. So we're gonna start. So we've started the demo, and it's gonna tell us a lot of things that it's doing. You can see the mock codec storage here running. It would work with normal codec storage probably as well, or Logos storage. I've never tried it yet. Just very simple REST API mimicking that, just for this particular demo, so that it's a bit more self-contained. Now we can see the sequencer is running. It's producing block, so block ID 3 is created. So let's move on. So what do we do now? Now we need to deploy our binaries. So we take a token binary, so we can work with tokens. That should be already deployed actually, but we'll just see an error and it's gonna pass. We are taking,
right, you can already deploy
registry
tokens.
binary. We are taking our multisig binary and we are deploying them all. You can see here that we have one error, which is program already exists. That's the token binary, and we have 2 validated transactions, which basically means that everything else succeeded. And here we are just waiting a few blocks to make sure that everything is fine, and we can see that the programs are deployed. We've also created a signer account. This will be an account that we will use to sign some of the stuff. Nothing special about that. It's just a new wallet account. Now we are calling registry register. This is again the rename to spell and spellbook happened after we tagged this version 0.1.0.
Always.
So this is called the old name. It will be spellbook register, but this is fine. So it's registry register. We pass in some information. So
I mean, I think both are okay. I like spellbook registry better than registry register.
we take the name of the program, we take the version, we take the CID of the IDL, the structure that describes how the program can be called with what instructions and things like that, and we submit it. So we have registered the token, we have registered the multisig. Now, next thing to do is we know that the registry is live, and we can fetch from the registry. So we can see that registry has 2 program registers. Amazing. So now we're good. So we're going to generate a bunch of new wallets. We're going to generate signer, which is going to be the initial member of our multisig. And we're going to generate member 2 and member 3. And we're going to submit some transactions. Here we are submitting create multisig transaction. This is going to auto compute a multisig state account, because LEZ has separated state accounts from programs. So program code has program code has separate account from the actual state, and then we are submitting the member accounts. And you can see the transaction has passed. We can see it here executed as so. And so now we have the multisig created, and we have the state PDA here. We can inspect it if we wanted to. Now the next thing is to do a proposal, and we're going to propose a second member. So we're going to create a new account using the wallet again, and we are saying using the multisig state, and we are doing a proposal for propose add member. We have special member management instructions. So these are not standard proposals. These are slightly modified because they are not interacting with an external program. But we have submitted that, and the proposal has been created. It's basically also auto-approved because we have one of one signers, right? The threshold is 1. We had just one member, and so it's basically auto-approved. So we can immediately execute. We don't have to wait for another approval. Now this is executed, which means that the code actually updated, or the multisig actually updated the signers, so the members of the multisig. And what we can do is that we can create another member, and we can propose it as well. So we're creating another proposal for a new member, and we have that automatically approved as well because we still have threshold 1. So in the future step, we will actually bump the threshold. So now this is executed, and now we want to do a proposal to new threshold because we now have 3 members and we want to do 2 out of 3 signing. You can see in the sequencer here on the right that these messages basically mean that something got executed in 14 milliseconds. It's a risk 0, so ZKVM, so the program gets executed in that ZKVM in 14 milliseconds, and then there is a new transaction, which is basically how we know that everything worked, is that we watch for this transaction to be included in a block, and when it happens, we get this confirmation based on our polling, right? So here we have proposed, using propose change threshold, new threshold to be 2. We've passed a bunch of other params. You can basically see that here. So it's transaction index 7, this instruction, propose change threshold, new threshold. The create key is an identifier of the multisig wallet, and then the proposal index. So basically it's an always incrementing index of a proposal so that we can generate these proposal PDAs, these accounts that hold the proposals. Now this is proposed, and again, because it's auto approved, we can immediately execute because we still had the threshold 1 for this. So now this was kind of lame because we were just managing members, and that's kind of boring. But what we can do now is that we can actually do some token governance. So let's take a look at what's happening here. So we're gonna create this new.
Now it gets interesting.
We're gonna calculate this new PDA.
It's all interesting.
For multisig. We call it multisig vault, but it's basically just PDA created based on the multisig program ID and create key, and we pass this PDA to a wallet token sent transaction. So we create a new token. We call it LEZ token, and so we now have some account holding 1 million of LEZ tokens, and we will fund this vault, right? And so we send a wallet token sent from to amount 500 transaction, and once that's approved, once that's processed by the sequencer, we will now do a proposal. So we have this token IDL JSON, which is same as the multisig IDL and the spellbook IDL. It's a definition of how to call program instructions on the token. We have derived it from the code. It's not generated like the others. But the IDL drives the serialization, right? So we don't have any hard coding of instructions, of the instruction bytes or anything. Based on this, we can use our CLI to generate a transaction data. And we do right exactly this. So this multisig binary is actually just a wrapper over the spell CLI. And so we pass it the token IDL JSON. And now the CLI, and I'm going to show that, generates, auto-generates the subcommands, instructions based on the token IDL. And what we do here is that we take the token binary so that we can derive the program ID. We pass dry run, which means we do not actually submit anything. We only create the instruction bytes. And then we take the transfer, or we call a transfer instruction and say amount to transfer is 200. And then we pass the accounts. So who is the holder, which is our vault, and who is the recipient, which is whoever, a newly generated wallet, basically. It doesn't really matter. And we say how much to transfer. And then we serialize it. And so this is basically the serialized instruction data, and we have all this other information that we can pass in, right? And based on that, we do a proposal. So we say, we propose that we will call a target program ID token program, and we will pass in this instruction data. And we will also, I believe, have to use some of the accounts. So we will pass in some of the accounts as well. And then we will submit this. And then that means that sequencer accepted that, and we now have a proposal that should send 200 LED tokens transfer as a chain call from the vault to some new address. And now we have to approve, right? So we have one member proposing, so we have 1 out of 3, and we need 2 out of 3 because obviously we have bumped the threshold. So we have multisig approve proposal index 3, which is this third proposal, and the approver would be the account address of who is approving, and it has to be signed by that as well, right? And so this is exactly what happens here. Approver, proposal, multisig state, all passed in or calculated based on the parameters. And this is the instruction, approve. And as we submit it, it happened already, sorry. I need to put pauses on the right places. But basically, the N2 approved. So we now have 2 out of 3 and we can execute. And so what happens here, and that's super interesting, and I had so much trouble actually making it work because I made some stupid mistakes. But basically, we call multisig execute, and we pass in proposal index, which is 3, and the target accounts, which is what needs to be passed in for the actual transaction to be executed, because the program expects accounts in a specific field, and so they have to be passed in a specific way. That's basically abstracted away by the CLI mostly. But we don't have to pass in the token program ID, we don't have to pass in the instruction data, we only have to say which accounts are part of this proposal and how this proposal is indexed, right? And then what happens is that if we go up here, we would see, I believe this is this. So we can see that there are 2 executions. And so that means that this is execution for the actual execute in the multisig program. But this second one is an execution of token program. That what it does is that it actually sends the 200 tokens from one account.
200 tokens.
And that's it. We can also do a lookup query. So calling registry info with program ID will give us the information registered in the spellbook. But we have went through all these steps, right? So we inspected some IDs, we've deployed all the programs on chain, we've registered stuff in spellbook, we have listed the spellbook, we've generated fresh accounts, created multisig, proposed a bunch of things and executed them.
All right, don't get it twisted, as that was a lot packed in. But all of these things that Václav is so generously listing are all of the things that he has already done for you so that you do not have to. You, the program and token engineer who is hungry to build on Logos Testnet v0.1, which is live now. So I highly encourage you to rewatch and consume the content that Václav is putting out.
And then we have raised threshold, and then we are missing here step 10, which was the longest one, which is we actually did a proposal to approvals and a token transfer. Now, when I'm talking about this binary, right, the magic binary that kind of does it all, let me see, debug multisig, right? So if I just hit enter, it doesn't look like much, right? It's asking for an IDL file, and all things I can do is I can call init, which is just going to spit out a new project, and I can call inspect, which will print a program ID of a binary, which is very useful, honestly. And then we have PDA, which is also very useful if you need to calculate
Public
some
display
PDA,
protection.
like the Vault PDA, the program-defined account, derived account.
Program-defined
So those are accounts that are managed by other programs. We need to calculate the address of this because it's derived deterministically. We can do it by calling this command. Now, we didn't pass the IDL. Well, we can do that. We have it here, and IDL, I think it's LEZ multisig FFI, because we also generate FFI for integration into Logos Core. And you can see that here we have multisig JSON. So if we call that, we get much more help, right? I'm gonna make it full screen. Sorry, it went the wrong direction. So we get much more help. So we get a bunch of other options, and we get all these commands. All these commands are instructions implemented in the multisig program, auto-generated from the IDL, which is auto-generated from the code of the program, right? And so we can see all these parameters and all these things actually being provided for us. So when we can try, for example, create multisig, help, and it also gives us like create key, which is any string less than 32, what is the threshold of the multisig, and members which need to be passed in. And so we can then do this for registry, for the token. We can actually try it with the token IDL probably as well. So that will be in the LSSA there. LSSA there. But let me look, where is the token binary living? Token IDL is token bin. Where is our token IDL? Token. We seem to have a wrong token IDL here, but I think we have been using it here somewhere. So where is the dry run? Dry run token IDL here. Right, it's here in the same there. Sorry, scripts, because we have just auto-generated. Sorry, not manually generated it, so it's not there. And if we do this, we can see that these are all the commands or instructions that the token program allows us to do, and you can basically see them also here in wallet token new send burn mint, right? And so we have new fungible burn mint. This is a bit wrapped. This is very kind of raw based on the program. Anyway, this has been the demo. You can run this on your machine. Just make sure to clone, basically to clone these repositories. So they can be moved to Logos blockchain, LEZ multisig framework, spell, and spellbook. You don't need spell. You need spellbook and the LEZ framework. Check out the v0.1, and then there in the scripts, the demo flow should hopefully work for you the same way it did for me.
All right, so that is an important point there that Václav just made, in that the repos that you would be looking for if you want to dive into this are the LEZ multisig framework and the spellbook and the spell repos, respectively. And that is Jimmy-Claw. Jimmy, of course, is Václav's trusted agent. Now, I can't stress this enough that Václav is an absolute must follow if you are building on Logos or aspire to build on Logos. Václav is the chaos agent, as he puts it in his bio at Logos. He has an abundance of experience building open source tools and working with other open source developers. So certainly reach out to him. And if you do attend a Logos office hours session, it's very likely that you will be speaking with him. So bring your technical questions to those sessions or to him directly or any of the Logos ecosystem engineers, Guru, Donish, Sasha, Václav, Frank are all there and building to help you build. So do follow Václav's account and his work, more importantly. Now, we saw one demo from Alisher earlier. We're going to see another live demo that he put together for his encrypted notes app running on Logos Basecamp. And here is Alishar. Complex pin. Oh no, folks. I realize now. I don't think the audio is working. Nobody said anything. All right. Before I go further on a no audio situation, uh, apologies for that. Alishar, again, core contributor, key card, logo status, long time very much worth a follow. He's putting out a ton of content. Very quickly, want to highlight a post from Pier Giorgio covering Parallel Society, which just very recently passed, March 6th and 7th, it was in Lisbon. And it was a very special event for many reasons. I think this is one of the favorite posts of mine of covering their experience. And so I will just read a bit of it. TLDR, gathering around values is far better than gathering around a chain, a coin, or specific tech. Parallel Society Festival was a great attempt to cross-pollinate our scattered efforts to confront authoritarianism and injustice, bringing together policymakers, lawyers, and lobbyists with prime hacktivists and artists and enthusiasts and community organizers. And all of those groups were very well represented, and they are tagged in the post if you want to visit it. But hours and hours of workshops, open discussions, presentations, speeches, demos of Logos tech, Logos nodes being given away. And that was all just on day one. That is not to mention Apparat and all of the other music acts that were featured on day two. And it truly was an incredible event. And this is just a snippet of Jared's speech from the event. And I'm hoping, really hoping that the audio is going to work on this. So let's see. Yeah, I apologize. For some reason, my audio sharing has just completely gone kaput, and it's really cramping my style. Oh well, that is how it goes. We shift and morph, keep our head on a swivel, and change on the fly. Since my audio sharing is unreliable at the moment, I will turn your attention to the Logos Press engine, where lack of audio won't stop you, because this is where you read and find all of the content. The most recent article published a few days ago, The Secret to Sovereign Zone Interoperability on Logos. I said it at the top, I'll say it again. All of the content that you can expect to find is and will be on the Logos Press engine at press.logos.co. And that is where you should look first. Now, wherever you might be watching this stream, if you could give us a like and a subscribe or a follow and turn notifications on, that would help quite a bit. Now, Logos Basecamp is live. Logos Testnet v0.1 is live. There are about 4 other demos that I can't get to without reliable audio. So those will be coming to you on some of the Logos Dev Club streams in the very near future. This coming Wednesday, the 25th of March, we'll have 0x0, who is probably the leading open source DIY, do it at home LLM mind. And Ciro will be joining Václav on a Logos Dev Club stream on Wednesday. We will have another one coming up on Monday as well, either Monday or Tuesday, as we juggle scheduling around. But over the next few weeks, you can expect all of the module leads, as we were looking at modules on the Logos Basecamp earlier, from storage to the Logos Basecamp app, messaging, non-comms, etc., blockchain. Gusto from the blockchain team will be joining us 1 week from Monday, so 2 Mondays from now. So this channel that you're tuned into now, is where you can find all of that. The Builders Hub at build.logos.co, or even more simply, logos.co, as you see it scrolling across the bottom of your screen, is where you start and get going, start building, start testing, run a Logos node, run a storage node, upload a file, retrieve a file, build whatever your heart desires with your favorite Claude bot, as Václav demonstrates to us day in and day out. It is all ready for you to tinker with. That is going to be it for today. We went just over an hour. We covered 3 demos. There are 4 in the hole that I will bring to you next week, including an imminent Logos storage demo, among others. Also have a Logos blockchain and Logos, I think some atomic swaps from Danesh are coming. We have previously played the Logos Scaffold demo from Sasha, which we will be playing again. But again, all of this and so much more can be found there at the Builders Hub, logos.co, press.logos.co. Until next time, and next time will be soon, I'm Chair. I am always here to prop you up. Did you hear that static? That's what I'm dealing with on the audio right now. There it is. This has been a short update. Testnet 0.1 is live. Todo es mentira desde el mundo. Todo es mentira la verdad. Thank you very much, everyone. We'll see you very soon.